Okay. Hi guys. Good morning. So there was a small problem here. I had no charge, no internet. So that's why I couldn't join. Okay. Right. So we'll continue. Right. So we were talking about elimination reactions. Right. So elimination reactions are where I'm going to remove one H plus and there is going to be one leaving group and it is going to leave. Right. So there can be two ways by which this can happen. One is by E1 mechanism, another is by E2 mechanism. And this 1 and 2 represents that I'm going to have uh, the molecularity. Basically, you'll study more about it in 12th class. So you will the rate depends on how many species, whether it depends on one species or it depends on both the species. Depending on that, I have to one or two, right? So then all these things. Hope you should remember. I don't have to spend so much time on this, right? Okay. Why is it like this? Okay. Okay. Now, obviously, we know you saw in the product, right? After the elimination, the only product which is possible is actually going to be my alkene. Correct. Right. So we saw the overall mechanism. We saw what are the ways by which it can happen. But what we don't know is how exactly, what exactly is the reaction itself. Right. So the first one, right, is we basically are looking at preparation of alkenes. That's what we are doing. Right. We're looking at preparation of alkenes. Right. Okay. So first I'm going to do it from alkyl halides. Okay, from alkyl halides. Right. Okay. For example, right, if I have CH3, CH2, Ca. Okay. So now here the reagent which I have to use, right? It is going to be alcoholic KOH. Right? So what do you mean by this alcoholic KOH? Alcoholic KOH is nothing but KOH dissolved in alcohol, not water. Remember, it is not an aqueous solution. If I put KOH aqueous, I will have some other reaction happening. I'll tell you what is the reaction for now. Please understand that KOH dissolved in alcohol. They might even represent this like this: KOH in the presence of ROH, something like that. This is how this way also it can be represented. Okay, so what is going to happen here is that I'm going to have elimination happen, right? So how elimination? So Cl from this, right? And I'm going to remove one of the hydrogen from the next atom, chlorine, hydrogen. So you will form CH2 double bond CH2. Okay, CH2 double bond CH2. Easy. Cl from this, H from this, right? Now, whether it is going to follow E1 or E2 depends on what kind of substance. This is a primary alkyl halide, right? So definitely it will undergo E2 mechanism. But anyways, you don't have to worry about it. Okay. So this is yeah. So Cl from this, H from this will form alkene. Right. Now, if at all you have a mixed product, in the sense, if this is okay, you can have only one type of alkene formed. Right. Now, what if I have something like this? Okay, I have something like this, and say I put KOH in ROH. Okay, now what will happen is, okay, what is going to happen is you will see that this chlorine will leave, no issues, right? Now you see that this, what you have to understand is you are always going to remove the hydrogen from the next carbon atom. Correct. Now this what is that? Chlorine from this carbon atom will go. So now you have two possibilities for removing hydrogen, isn't it? One possibility is removing hydrogen from this position or removing hydrogen from this position. Okay. So accordingly, I will have two different products, right? Say, can I say if I remove hydrogen from this, the first carbon atom, I can say that it is going to be CH2 double bond CH CH2 CH3. This is one of the products removing hydrogen from this, right? Now, if I remove hydrogen from this, right, what will happen? Can I say this and this will be another product? CH3, CH, double bond, CH, CH3. This would have been another product if I remove hydrogen from this carbon atom. Right. Now tell me, you must have learned this in school. Which is correct? I mean, which is going to be the major product? Well, obviously, one is going to be in higher amount and another is going to be in lower amount. So if I make it as 1 and 2, tell me which is in higher amount. Hmm? Which will be in higher amount, 1 or 2? Hello? There isn't. Yeah, people are there. What happened, guys? Are you there? Hello?
Yes, sir. 1 minute, sir.
Okay. Yeah, you're there. You're there. Okay, fine. So if I have this as 1 and this as 2, I will anyways tell you the answer. I'll anyways tell you the reason also. But now that you have already learned this in school, tell me which one will be higher, which will be a major product, and which will be the minor product. Okay, maybe I don't know. Right. So for these kind of problems, in the sense that for these kind of issues, when you can form two different alkenes, this is bute 1-ene, this is bute 2-ene, right? So two different alkenes can be formed whenever you have this kind of. Can you tell that reaction again? Yeah, why not? So here what happened? You have elimination, same elimination only. Cl from this, and I have to remove either hydrogen from this carbon atom or this carbon atom, right? So if I remove hydrogen from this carbon atom, double bond will be formed between these two. So you see double bond will be formed between these two, right? Now if I remove hydrogen atom from this, right, now double bond will be formed between these two carbon atoms. So you see double bond is formed between two carbon, obviously, and plus both this thing, I'll have HCl removed. H from this, I mean H from either of the carbon atoms, and Cl from this carbon atom. Okay, right? Okay. Now, whenever you have this kind of problem, whenever you're going to form two different alkenes, which one will be in major amount, which one will be in smaller amounts, that will be decided by something called as Said-Zepf rule or Said-Zepf's rule. Did you hear this about in your chemistry in your school? Said-Zepf rule. Did you know about? Did they teach you about this?
No, sir. They taught about Markovnikovs.
Markovnikovs. Okay, fine. You can know this also. Take down the rule. Anyways, we'll study about it in 12th class. But I don't know then how they taught this reaction, alcoholic KOH. Did they teach this reaction?
Sir, check.
Okay. Anyways, cool. Like even if they didn't, they should have thought. Or what other methods you have for preparation of this? I don't know. This is a very simple method. If this result is not there in NCRT, okay, no issues. Take down the rule. Says rule. Right. So in case of elimination reactions, in case of elimination reactions, the double bond is formed. The double bond is formed between the carbon atoms. Between the carbon atoms, which are more substituted. Which are more substituted. right? That's the rule. So the double bond should be formed between the carbon atoms which are more substituted. As simple as that, right? Now, at least, what do you mean by substituted? Substituted means it must be attached to more number of carbon atoms. That's what you need to understand. Okay. Now you see, if I take these two carbon atoms, right? Now this carbon atom is attached to two hydrogen atoms, and this carbon atom is attached to carbon atom. Okay, fine. We'll check for this. Now you see this carbon atom is attached to one carbon atom, and this carbon atom is also attached to another carbon atom. So obviously this is more substituted than this. Substituted means the two carbon atoms having the double bond, right, is attached to more number of carbon atoms than in the previous case, right? So according to Zaitsev's rule, this will be the major product and this will be the minor product, just like Markovnikov's. Okay. Now you have to remember that the double bond will be formed in the carbon atoms which are more substituted, right? So if I have to give you another example, okay, can you predict the product, major product? This is a, if I don't write anything, this is a methyl group. Okay, there's a CH3 here. 2-methyl bro. Yeah, this is 2-methyl bromohexane. That's the name of the compound. Tell me what is the product? Right. So basically, when I put alcoholic KOH, you're going to remove HBr. In this case, HBr will be removed. Right. Okay.
Done, sir.
Fine. Yeah. So you will remove Br from this carbon atom. No issues. So now you can remove hydrogen either from here, right, or you can remove hydrogen from here. Correct. Either this hydrogen or this hydrogen, the next carbon which is having the halogen, right? So obviously now you have two products, right? Say now one CH3 is here. Now if I remove hydrogen from here, you would have formed a double bond here. Now another case, right? Now you remove Br from here or H from here. Now you would have made a double bond here with CH3, right? So obviously you see, right, this is more substituted. So this will be the major product and this will be the minor product because the double bond is formed between carbon atoms which are more substituted. That's it. So this is the major product. How many of you got this answer as the major product? How many of you got it? Nobody got. Okay. At least now
So for the major one, that CH2 or CH3, sir?
this is CH3 only. Methyl group. Okay. Understood how is it major product? Right? Here you had hydrogen, here you had two choices you had. But if I remove hydrogen from here, I'll make a double bond here, which is more substituted. See, this carbon atom is okay. That is Br it had. But this carbon atom is having a methyl group. Right? But this carbon atom, if I remove hydrogen from that, now there is nothing actually. Right? That's why we go for putting double bond here and not here. Okay,
so
everybody
understood.
Right? Okay, so that is about alcoholic KOH reaction, right? Right. Okay, moving on. I actually have to check what and all are the reactions they have given. Right. So that is a way of preparation of your alkene, right? Other ways are also there, right? One more way by which, by elimination only, you will be able to prepare alkenes is by from alcohols. Okay, so from alcohols by a reaction called as dehydration. Okay, by something called as dehydration. Very, very simple. Exactly same thing we are going to do as in the case of your alkyl halides, but instead of Cl or Br, you have your OH here. Okay, right. So here I have to put some dehydrating agents. Right. So if I put some, I'll tell you what are the dehydrating agents. Okay. So if I put the dehydrating agents, OH from this, H from this will leave to form CH2 double bond CH2 plus a water molecule is eliminated. Plus a water molecule is eliminated. Okay. Right. Now, what can be dehydrating agents? There are certain lists. You can use concentrated H2SO4, concentrated H3PO4, you can use P2O5, or you can use Al2O3. Any of these things can act as dehydrating agent. Okay, and the best choice would be concentrated H2SO4. Okay, so concentrated H2SO4 is capable of removing water molecule. Okay, OH from this, H from this, you will end up with CH2 double bond CH2, and for this also Zaitsev rule is the thing for any elimination reaction for that matter, right? For any elimination reaction, Zaitsev rule is the rule which you have to follow when you have choice between forming two alkenes. The alkane which is more substituted should be formed. Okay, right? So that's about preparation of alkenes. Right, so we saw three methods, right? Four methods. One is by normal hydrogenation from alkyne. Second one is using sodium and liquid ammonia. So what is the thing? If I use hydrogenation reaction, I always end up with cis alkene from alkyne, right? And if you have sodium and liquid ammonia, you always end up in trans alkene. Sorry, right? And the third and fourth one are by elimination. First one is from alkyl halides. Second one is from your uh, alcohols by dehydration. Okay, right. So that's about preparation of alkyl halides. Sorry, preparation of alkenes. Right. Moving on. Right. So at last, your alkynes. Okay, alkynes is preparation. Right. Now there are not so much methods of preparation of this thing. I don't know whether this reactions are there in your textbook also, but still I'm giving you maybe one reaction I'll give you. Say if you had you had something like this, okay, and you go for 2 times alcoholic KOH, okay, 2 times alcoholic KOH. So what is going to happen? Cl from this, H from this, Cl from this, H from this, 2 times will happen. Just like last time, only one time it happened. In this time, it is going to happen 2 times. So you'll end up with alkyne here. Elimination only. Okay, by elimination reaction only, I'll be able to prepare this. Okay, right? So there is not much you have to know about alkynes preparation. Okay, so yeah, that's about the preparation part. Right, you have prepared alkanes, you have prepared alkenes, you have prepared alkynes also. Right. Okay. Now what we'll do is we'll move on. We will move on to the chemical properties. We'll move on to the chemical properties. Okay, right. Fine. First, we'll take alkanes. Okay, alkanes is chemical properties. Right. Okay. Now there is only one reaction which you have to know for alkanes. Actually, there are okay, fine. One main reaction is there for alkanes, and that alone we'll see. That is my free radical substitution. Right, free radical substitution. Okay. Right. So here we'll see what is going to happen. So you can see, you can understand there is something to do with free radicals. We know what are one of the intermediates which can be found in our organic chemistry is free radicals, right? Okay. Okay. So what is going to happen here? For example, if you had CH4, right? If you had CH4, now if you use chlorine in the presence of some energy source, H nu can be either heating or it can be light. Any form of energy you have to give. Okay, chlorine in the presence of heating or chlorine in the presence of light, sunlight, right? So what is going to happen is I'm going to remove one of the hydrogen, substitution reaction. That means one thing will be replaced by another thing. Okay, so you will remove one of the hydrogen atom and you'll put a chlorine atom into that, right? So you will form CH3Cl plus HCl. Right now, if you have enough amount of chlorine, right, if you have enough amount of chlorine present, this reaction can continue. Cl2 in the presence of H nu, one more hydrogen atom will be replaced by another chlorine atom. Say I will form CH2 Cl2 plus HCl again, right? Now this reaction can again continue. If you have enough amount of chlorine, you will form CHCl3. This is called as chloroform. Chloroform, I don't know, in your movies you would have seen people, they'll use some spray in the kerchief and they'll keep, and the person will become unconscious. So that is what is this chloroform, right? CHCl3, right? So again, this can continue with one more. You'll end up with CCl4, carbon tetrachloride, right? So this is also a very good solvent, carbon tetrachloride, chloroform. All these are good organic solvents. Okay. So yeah, so as long as you have the chlorine supply, right, and as long as you have hydrogen atoms to replace in the molecule, this reaction will keep on continuing. Okay. Now what I have to understand is the mechanism. What is the mechanism of this reaction? That's what we need to know now. Right. Okay. So we'll see. Right. So whenever you have free radicals, so from the name itself, we know that free radical is going to be an intermediate. Okay. So whenever you see that free radical is an intermediate, there will always be 3 steps. Okay, not only in this reaction, any reaction, if you find that the free radical is the intermediate, right, you will always have 3 steps in those kind of reactions, right? So what are the 3 steps? First step is what is called as your chain initiation step. Right, that is what is called as chain initiation step, right? So what do you mean by this? It's pretty simple. So you have the Cl-Cl bond. Okay, now this Cl-Cl bond has to be broken, obviously, correct? So when I supply the heat or when I supply the light, right, so this bond will undergo homolytic cleavage to form 2 chlorine radicals. Okay, 2 chlorine radicals, right? Okay, fine. Then what is going to happen is, second step is what is called as chain propagation step. Chain propagation step. Now here it's like CH4 is there, right? Now this CH4, when I in the presence of the Cl dot, in the presence of the Cl dot, it is at this Cl dot is going to abstract one H dot, H radical. Say when I put Cl dot means chlorine radical, right? So what is this? One of the chlorine radical, what is it going to do? is that it is going to take up one of the hydrogen radical from this CH4. Right, so what will be product will be HCl. One product will be HCl. H from the Cl dot, H dot, Cl dot will again come together to form HCl. Now what will be remaining here? Remaining would be CH3 dot, methyl free radical will be there. Okay, this is the second step. First step, chlorine will undergo homolytic cleavage to form two chlorine radicals. In the second step, called chain propagation, one of the chlorine atom will come near the methane molecule and will abstract a hydrogen radical to form HCl and methyl radical. Okay, now the last step, right, is what is called as chain termination step. Okay, chain termination step. Now, very simple. You are going to now form the bond, right? So you already produced a CH3 dot, right? Now, you out of the two chlorine radicals, only one of them is forming HCl, right? There is one more chlorine radical left, right? Now, they both will come together to form CH3Cl. Did you guys see that? Yeah, right? You can see that here, CH3Cl. Okay, again, I repeat, initiation, breaking of the Cl-Cl bond homolytically to form two chlorine radicals, right? Next step is the chlorine, one of the chlorine radical will come near the methane molecule to form HCl and a methyl radical. Now, in the last step, chain termination, methyl radical and one more chlorine radical will come together to make a bond to form the alkyl chloride, CH3Cl. Everybody understood this mechanism?
Yes, sir.
Yes, sir.
Okay, good. Right. So yes, that's about the free radical substitution. Okay, fine. Moving on. Right, other reactions are possible with respect to your alkanes. Right. There is something called as pyrolysis. Right. So pyro means heat. Lysis means separation. Right. So when I say pyrolysis, I have a very big molecule. Right. Now that big molecule, by supplying some amount of heat, I am going to break down that big molecule into smaller molecules. That's what is called as pyrolysis. Pyro means heat, lysis means separating. Right. Say if you had something like C20 H20 C20 and H something H40, something like that you had. Okay, some very big molecule you have. Okay, now if you're going to supply heat, right? Say I can form so many types of compounds. There is no restriction. Say you can form some C5H12, or say you can form C4H10. Now say C2H6 will be one of the product. Hydrogen can be one of the product, right? So like that, I can get so many products. Okay. Now there is no restriction that you have to form only these kind of products. Okay. So this is just actually not an important reaction, but you have to understand that this is also possible. Okay, this is also possible. Pyrolysis, right? When you strongly heat a very big compound, it'll break down into smaller units, and there is no really restriction that what kind of smaller units you're going to form. Okay, right? So that you need to know. Okay, next reaction. It is not only alkanes, right? It's actually any hydrocarbon can give this reaction. You can even see a C20H20, it's like CnH2n. Correct, right? So it's not necessarily alkanes alone will give this. Okay, it can be any hydrocarbon which can give this reaction, pyrolysis. Okay, now third, this was second reaction. The third reaction is combustion. Okay, now combustion, we know what do you mean by combustion. Combustion means burning with oxygen. Right. Okay. So what is going to happen here? if I have any hydrocarbon, for example, say C2H6, right? Now, when I heat it with in the presence of O2, right? So remember, any hydrocarbon on combustion will always give me carbon dioxide and water, always, right? Any hydrocarbon on combustion will always give me carbon dioxide and water, right? But obviously, I have to balance the reaction, right? So if you want to balance it, this is going to be 2, right? So then I can say this is going to be how many O2s are there? Okay, if I put 3, so totally I have 4. 4 plus 3, 7. So I'll go and put 7 by 2 O2. Okay. So anyways, you have to balance. Sometimes stoichiometry problems can come from this, right? Stoichiometry problems is mole concept problems, right? Based on they'll tell that propane is undergoing combustion, right? Some amount of propane is there. Find the number of moles of CO2 formed, right? Or find the number of moles of H2O formed. Like that questions can come. So what you have to know is that if any hydrocarbon on combustion will always form carbon dioxide and water, but you just have to balance it. That's it. Okay, right? Fine. So that is about your combustion reaction, right? Now that is about the reactions of alkanes also. Alkanes are done, right? Now we'll move on to alkenes and alkynes. Alkenes and alkynes have similar chemical properties. Okay, right? But except for alkynes, which has little more, we'll see what is that anyways. Okay, alkenes, chemical properties. Okay, now there is only one reaction possible, that is my electrophilic addition reactions. Electrophilic, very famous reaction, right? Electrophilic addition reaction. First of all, right, you need to know what do you mean by an electrophile. Okay, now please understand, I told you that there are something called as substrates, right? And those will be attacked by something called as reagents. That's what I told you, isn't it? Now this reagents can be of two types, majorly two types. There are so many other types, but majorly you have something called as nucleophiles and you have something called as electrophiles. Okay, nucleophiles and electrophiles, right? So what do you mean by nucleophiles? What do you mean by electrophiles? Very simple, right? Nucleo means nucleus, positive charge, right? Phile means loving, right? Nucleophile means positive charge loving species, right? So definitely there should be excess negative charge in these compounds, I mean, or in the reagents. Only then they will have love for positive charges, positive centers. Nucleo is positive, phile means loving. They are positive centers loving species, right? Okay, now right. So this nucleophiles, what can be examples? Now this again can be of two types. Nucleophiles can be of two types. One is neutral nucleophiles. Another is charged nucleophiles. So obviously nucleophiles will be negatively charged because they have to attract the positive charges. Right. So neutral. Say first we'll talk about the charged nucleophiles. Say Cl minus, OH minus, Cn minus, H minus. Anything which has negative charge comes under charged nucleophiles, right? And so neutral nucleophiles are going to be in the form of lone pairs, right? Say for example, H2O with a lone pair, ammonia with a lone pair, say amine with a lone pair, right? All these things can be called as neutral nucleophiles. Okay, fine. Now going to electrophiles. Now electrophiles again can be of two types. First, you have to know what are electrophiles. Exactly opposite of nucleophiles, isn't it? Electro means electrons, negative charge. Philes mean loving, right? So they are negative charge loving species. So definitely they should be positive charges or they should have deficit of electrons. Either way, right? So now again, this can be visualized in two ways. They can be neutral or they can be charged, and obviously in this case they'll be positively charged. Okay. Now neutral things can be, say, any Lewis acid, because they will have deficit of electron, say BF3, AlCl3. All these are going to be good Lewis acids, which already have lesser number of electrons than what is required, so they can accept more electrons, right? Okay. Now anything which is positively charged, a H plus, some say it is even possible that you can form Br plus, right? Anything which is positively charged, anything which is positively charged will come under your charged electrophiles. Okay, right. Now what you're looking at here is electrophilic addition reaction. That means you are going to add an electrophile to the double bond. Okay. Now you just have to know that there's the what is an electrophile, and the other things we know already, right? The reagent, substrate, all these things we already know. Okay. So we'll see what are these electrophilic addition reactions now. Okay. Right. So for example, right? For example, if I had CH2 double bond CH2 alkyl, right? Now, if I add HCl to this, okay, or HBr to this, right? So what will happen? We know this is what is addition reaction, right? H will go to one of the carbon atoms and Cl will go to another carbon atom. So you will see that I'm going to form, say, CH3, CH2, Cl. It is exactly opposite of the elimination. Addition reaction and elimination reactions are exactly opposite. Correct, right? So that is what is called as addition. Now, why am I calling it electrophilic addition is the question, right? Now, what you can understand from this species is that I will have H plus, right? And I also have Cl minus, right? I have H plus, I also have Cl minus. Now, then see, you have an electrophile which is positively charged, you have a nucleophile which is negatively charged, right? Then why am I calling it specifically electrophilic addition? Is the question that'll come to your mind, isn't it? I have a positive charge electrophile, I have a nucleophile which is negatively charged, right? But in the reaction, I have mentioned that it is going to be an electrophilic addition reaction. So what is the reason behind it? Right now, the reason behind it is, even though I have plus and minus, even though I have a positive and negative charges, it is the electrophile which comes and attacks the carbon atom first. Then comes the nucleophile. It's not like they will go together and attack, right? First, the electrophile attacks, and then the nucleophile attacks. So just because I have the electrophile attacking first, I am going to call these reactions as electrophilic addition reactions. Okay, understood? Why is it that I'm calling it electrophilic? Is because the electrophiles attack first. That's why. Okay. Now, if at all, if you look at the mechanism, you'll understand what exactly is happening here. Okay. So I have this CH2 double bond CH2, right? Now, if I have H plus, okay. Now, this H plus can either attack this carbon atom or this carbon atom, right? Say if this attacks this carbon atom, right? Then this pi bond will come here, and this will come and attack the this carbon atom. All right, obviously, right? Because this pi bond will break heterolytically, there will be a negative charge, and the H plus will attack here only, right? And this carbon atom now has lost electron, right? So how will you write it? Okay, I'll write it as CH2 plus CH3. No issues, right? So because you see the electrophile is the one that is attacking first, you'll always form a carbocation. This is a carbocation intermediate, right? Now after that, what will happen? Obviously, you have a positive center. Now comes the Cl minus. Now this Cl minus will go and attack this carbon, right? So what will be the product? Product will be CH2Cl, CH3. Okay, CH2Cl, CH3. Exactly. Or say CH3, CH2Cl. Either way, it's going to be same. Right. So hope you understand why is it called as electrophilic addition, because first the positive attacks, then the negative attacks. There is something called as nucleophilic addition also. Not in here. When I go for aldehydes and ketones, right? You will study in 12th class. You will there is something called as nucleophilic addition. Now there also you will have an electrophile nucleophile. But at that time, what is going to attack first? At that time, nucleophile will attack first. Anyways, when we go for 12th, at that time we'll see those reactions. Okay, right? So now you understood, right? Now again, if you have choices between two products formed, just like you had Saitz's rule, right? We are not going to, obviously we are going to see Markovnikov's rule, but we are going to understand the reason behind it. Okay, now the reason behind it is, what you understand is there's going to be a carbocation formed, right? So a more stable carbocation should be formed. That's the point, right? For example, let me tell you, right? Say if you had CH2 double bond CH3. Okay, now say I go for HBr. Right, now there can be two products. Right, one product can be CH2Br CH2 CH3, and another product would be CH3 CHBr CH3. Okay, these two are the products possible. Okay, right. Now I have to understand, we already know the mechanism. I already told you, right? So obviously you understand that carbocation is the intermediate, right? So in whichever case you are able to form a more stable carbocation, that will be the major product. And whichever is able to form a lesser stable carbocation, that will be the minor product, right? Okay, so we'll try to understand what is happening here. Right, okay, so if we try to understand, now say I have obviously from this H plus coming first. Okay, now if H plus, say for example, if H plus attacks this carbon atom, if H plus attacks this carbon atom, obviously you see the electrons are lost by this carbon atom. The electrons are lost by this carbon atom. So what is going to get formed? CH3 CH plus CH3. There is a secondary carbocation formed, right? There is a secondary carbocation formed, right? Okay, if the H plus, let me write it here itself. Let me write the same compound, CH2 CH3 H plus. Now say this goes this to this, and the H plus attacks here. Okay, now what is going to happen? I'll form CH2 plus CH2 CH3. Yes. Okay, if H plus attacks here, the positive charge will be got by this carbon atom. Same way, if H plus attacks here, H plus attacks here, the positive charge will be got by this carbon atom. Okay, no issues. Now in this case, what you see is a primary carbocation. Okay, now tell me which is more stable, primary or secondary?
Primary, sir.
Which is more stable? Carbocation, which is more stable? Right, hope you understand. You can go for hyperconjugation, you can go for inductive effects, anything you choose. Tertiary will be more stable than secondary. Secondary is more stable than primary. Okay, so always secondary carbocations are more stable than primary carbocations. Okay, so obviously this will be formed in major amounts and this will be formed in minor amounts. And obviously to both of this, if I put the Br minus, right? Now, obviously, this would have given me this product if I put Br minus, and this would have given me this product if I've given Br minus. Is it not? This one will easily give this product because this is only the positive charge. Here only the nucleophile will come and attack Br minus, right? And in this case, the positive charge is here, and obviously the Br minus will come and attack here only. So you'll see the Br is the first carbon. Okay, so I can easily say now which will be the major product, which will be the minor product. I already told you this carbocation will be more stable. This will be formed in major amounts, and this carbocation is less stable, so this will be formed in lesser amounts. So obviously this will be the major product. and that will be the minor product. Okay, and this is what is given in terms of your Markov-Nichols rule, right? It's nothing. Markov-Nichols just analyze the stabilities of carbocations and he gave a rule, right? So even if you don't know Markov-Nichols rule, if you go by the mechanism, you will be able to answer these kind of questions. Okay, right? So anyways, now that you are going to follow Markov-Nichols rule, take down Markov-Nichols rule. Take down the statement. Markov-Nichols rule. Right. So in case of addition reactions, the nucleophile should be attached to the carbon atom. The nucleophile should be attached to the carbon atom, which is more substituted. Okay, I'll repeat the statement. In case of addition reactions, right, the nucleophile has to attach itself to the carbon atom, which is more substituted. Right? Very simple. Now you see, this is the carbon atom which is more substituted. So there only the Br will go. This carbon atom is less substituted because you said both side carbon atoms are there. This side only one side carbon atom is there. So definitely this will be the major product. Right? So either you can follow Markov-Nichols rule or you go by the mechanism, go for a more stable carbocation and accordingly form the product. You will anyways get the same answer to this kind of problems. Okay, right? So I think I will stop with this for today. Okay, so we'll continue. There are some other type of electrophilic additions also, and we'll see alkynes reaction, right? And we'll go for benzene reaction and preparation. And that's this chapter will be over. So I think tomorrow, hopefully, I should be completing the class, completing this chapter. Okay, fine. Thank you guys. We'll meet again.
Thank you, sir.
Thank you.